My dear students and learners, welcome to Engineering Thermodynamics, Unit 3, Steam and its Formation. Okay. So, the title of third unit is Properties of Pure Substances. And now in this video, introduction to the pure substances and how the steam is formed and utilized for getting the work. Just I'm going to give the introduction. Okay, so this is the course for third semester second year mechanical engineering students, and I am Dr. Suja, Assistant Professor Thandai, Periyar Government Institute of Technology, Vellore. Here in this slide you are just reading the syllabus for third unit. Okay, that is properties of pure substances and steam power cycles. We are going to cover two topics, that is we can classify this unit into two major topics. Okay, first we would be studying about the pure substances and its properties, various properties, and in the second part we will be continuing how the steam formed is utilized for power production in the power plants. Okay, so here the various topics are formation of steam and its properties, PVP, TT, VTS, HS diagrams, PVT surface 3D diagrams also, and use of steam tables, Molière chart will be taught, and determination of dryness fraction, which is one of the important criteria fixing the quality of the steam, and application of first and second law for pure substances, ideal and actual Rankine cycle, and improvising methods of reheat regenerative cycles, and usage of economizer preheater, and in both binary and combined cycles how the various cycles is being processed will be covered in this unit. And as I told in the first unit, we should know the purpose why we are studying this particular syllabus and the topics, and what is the outcome and how to achieve that outcome should be known to all the students, because then only effectively you can able to correlate the subtopics available in that unit to the topic. Okay, so that you can get a sequence of understanding, step by step understanding why you are studying the topic, what is the purpose of involving that particular topic in this unit, like that everything has to be correlated with each other. You have to manifest, and the various factors deals with this particular topic should be known to you. And another one more important thing is terminologies. Technical terminologies with respect to this particular topic should be known, because I already told you thermodynamics is the very fundamental and vital course, which makes the base for all other thermal related courses, right? So here course outcome for unit 3 is construct the property coordinates for steam formation process and apply first and second law to pure substances. For achieving this outcome, the objectives have been fixed to construct the PVP, TT, VTS, HS, PVT surface diagrams. No need to SCAD at all. These are all the terms already you would have aware in first and second units. And so this is coming under conceptual and procedural learning skill. To sketch and make use of steam tables and Molière chart, this is somewhat you have to apply your metacognitive knowledge to explore Rankine cycle and its improvisation methods. This is also the conceptual and factual things will be studied. To analyze economizer, preheater, binary and combined cycle is the procedural, and metacognitive knowledge is necessary to achieve this objectives. Okay, now First, let me explain what is steam, what is its importance in this thermodynamic. Steam is the most common working substance employed as a working medium in steam engines, steam turbines, and in atomic power plants for power generation. Okay, so you know very well. In first unit itself, I have told you what is working substance. Working substance means the fluid or the matter which involves in the energy transformation from one part to another part. So here we are taking steam, which is produced by any means of heat supplied to water and converted into vapor form. Okay, so there occurs a change in the properties of steam during a process, and that helps to attain the desired effect. Steam also finds application in process industries and also acts as a heat carrying agent in heat exchanger equipment. The part of heat exchanging equipment is also vital in all types of processing industries where all the materials is being processed and to get the desired effect in for various applications is being achieved by this steam because it is working as a heat carrying substance. Okay, so particularly this chapter deals with the process of steam generation, properties of steam, and heating and expansion process of vapors. The utility of Molière chart and steam cycles also is being taught in the solution of a problem dealing with the steam vapor will be also explored. Okay, so first here, before moving to PV diagram for a pure substance, let me define what is pure substance. Already I would have told in my first or second video in first unit itself what is pure substance is nothing but this pure substance is existing in single phase which consists of only single species with characteristic feature of being homogeneous and invariable composition irrespective of any phases or phase in which it exist. Okay, whether it may be exist in water or water vapor or ice, whatever maybe it will exist in the irrespective of whether phases or combination of phases. Wherever you check, its chemical composition would be same. Its chemical composition would be same. That is most important. And being homogeneous, okay, uniformity in chemical composition, and the existence of that particular matter, okay, it would be uniform and available as a single species. Wherever you check, it will be available in with the uniform composition. Okay, pure substance can exist in three different states, as already ice is a solid form of water, water is a liquid form, and again water vapor is the gaseous form of water. Water only changes its phase from ice to water vapor, right, because of heating. If you cool it, it would be dealing with the reverse direction, and that you can get the same phase again, right. A system composed of liquid and vapor phases of water is also a pure substance. You cannot tell that the combination of water and the water vapor or ice and the water is not existing in the single phase. It is a mixture type. So how can we call it as a pure substance? It is not like that. If you check that particular combination, the chemical composition would be same. They have the single species. Wherever you check, it would be in the molecules with H2O, right? That is most important. Okay, so now even if some of the liquid, if it is vaporized during a process, the system will still be chemically homogeneous and unchanged in chemical composition. Okay, and now now here to draw the PV diagram for the pure substance, we have to go by step by step. It is a very lengthy process. And so before moving to a particular application of how we have to prepare the water vapor from the ice, let me describe some of the basics. Now here we will be calling, however, it is not physically homogeneous because the liquid density is usually much greater than the vapor density. That is, if the water is existing, that is that water and the water vapor combination is existing chemically composition, it is not physically homogeneous, but they are chemically chemical composition is uniform. Air, which is a mixture of 79% nitrogen and 21% oxygen by a volume, can be also treated as pure substance if the composition does not change when it undergoes a cooling or heating or expansion or compression process. We are calling the air is also a pure substance, since wherever you check you can get the same combination of nitrogen and oxygen by volume or by mass if it is uniform in its chemical composition. But existing in more than single phase means it could be also considered as a pure substance until it does not change its heating or cooling and expansion and compression process. It should not have any changes. That is most important. Other examples of pure substances are the vapors of Freon 12, Freon 22 and NH3, that is ammonia, which are used in refrigeration and air conditioning process for producing the cooling effect. Okay, so here we have seen the pure substances. What is pure substances? It is homogeneous in nature. Its chemical composition is uniform throughout the matter. Its distribution is uniform. It is existing in as a single species. It may exist more than a single phase, but however they are not homogeneous physically. Okay, but chemically they are homogeneous. And if that particular substance is not undergoing any changes during the processes, then we can consider that matter also as a pure substance. Okay, and then now here what are all the various topics to be covered in this third units, or first in the initial stages of this unit 3, we will be covering how the steam is formed, when during the formation of that steam, how pressure, volume, temperature, enthalpy, okay, entropy, all these properties, that is state properties, is being changed, whether they are rising or reducing, or where they are being constant, why they are keeping as a constant, how they are plotted, everything will be studied in detail, because these are all the reactions or the basics for preparing the steam tables or the Molière chart. Whatever the tests or the reactions taken place by the scientists, and they have found out all the values, and then they made or they prepared the steam table chart and Molière chart. Okay, so these are all these two charts and the tables are utilized by us throughout the course of this third unit. And then however, after production of this steam, how this steam could be utilized in power plants, okay, to produce the work also will be studied. So these PV diagrams and other things, let me start in the next video, and I am Dr. Suja signing off now, and meet you in the next video. Thanks for patient listening. Thank you.